As the wind farm industry moves further offshore, aspects of remoteness of the site become more testing. This concept is designed for the construction and the operation and maintenance phases of these wind farm sites where it is not practicable to service the wind farm from the shore. The aims and objectives of the concept are to utilize existing technology, thus enabling the operation of a wind farm or wind farms from an offshore base. Aims and objectives of this concept: make the operation safer, reduce the carbon footprint of offshore operations, reduce long-term costs, create a more efficient utilization of time and machinery, improve living standards offshore for both technicians and operators. The concept is broken into 5 elements: the mothership, the daughter craft, the CTV vessels, efficient energy utilization of available clean energy, achieving the best performance of the workforce by way of access and personnel welfare. The mothership, a self-propelled DP3 jack-up barge chosen for its large deck area to store its daughter craft, giving it the ability to jack up clear of the sea in times of adverse weather without having to return to port or shelter inshore. It can carry out lifting operations for retro repairs on the turbine and turbine blades, in either DP mode as an SOV would, or in full jacking mode. Once jacked up at a turbine location, work can be executed safely. Each turbine is pre-surveyed for a jack-up positioning, along with other areas around the site that can be adopted as home bases depending in which area of the wind farm the work is taking place. The jack-up can be available at any time for retro repairs to any turbine, without the waiting time suffered by the industry to date. The daughter craft, a composite-built, fully autonomous swath, designed to transfer 9 people in up to 2 meters significant, and will be housed and maintained on the deck of the barge. Notice the 15-meter length is small in comparison to the CTVs currently working in this area, but the hull form allows similar transfer heights as the bigger 24-meter vessels. The daughter craft carries 9 technicians for 2 to 3 turbines, along with their hand tools and small parts. These vessels have a single-point lifting eye and can be lifted on and off the mothercraft by a heave-compensated crane in sea conditions of 2.5 meters. This vessel is 100% electrically driven via a hydrogen cell and charged by the mothership. The vessel is designed to be fully autonomous. Once the vessel has been lifted into the sea, the transfer platform extends, enabling the technicians to board the vessel. The CTV, a 20-meter surface effect vessel. This vessel is a mid-range transport for all regular heavier component part requirements. It has 24 seats and top speed of up to 38 knots, offering shore link for crew change when required. Its powered units are hydrogen cell powered water jets. It offers high comfort levels at very high speed with a zero carbon footprint. The CTV can be lifted onto the deck of the mothercraft by the means of a lifting ramp which has hydraulically driven thick rubber rollers. The construction of the vessel allows it to be rolled across the rubber rollers and onto the deck without the hindrance of props and skegs. This CTV is capable of transfers on the turbine up to 2 metres significant. With a cargo deck capacity of 8 tonnes, it is capable of delivering much heavier equipment to the turbines that the daughter craft cannot carry. Energy efficiency. In this concept, we have used hydrogen fuel. Being in the middle of multiple wind farms with the possibility of off-peak electricity and grid connection, we have explored the possibility of producing hydrogen on a plant mounted on a jacket-based platform. Using available off-peak electricity or a bespoke turbine, the hydrogen plant turns this energy into a battery bank of hydrogen. The hydrogen can be craned onto the jack-up to replace the spent cylinders of hydrogen. The hydrogen is then turned back into electricity to drive the jack-up's electrically driven motors and all other needs. This includes recharging the CTVs and daughter craft's hydrogen cell units. Personnel welfare. This concept offers high-end welfare to all shift personnel. This includes sport and fitness facilities, comfortable cabin accommodation, entertainment extending to an alcohol-free bar with areas for the off-shift socialising and relaxation, also offering good quality communications for contacting loved ones. Investing in people's welfare and downtime enjoyment is paramount for their productivity during their working hours. This concept has been designed with a home-from-home ethos in mind. The operation and maintenance needs offshore are far more difficult to deliver than an onshore wind farm. Therefore, far more drastic measures and initial investments are needed to achieve our goal. All of these aspects are designed to create long-term gains. As the world makes further investment into renewable energy, and the industry sets goals for production of cleaner energy, a new fuel production such as hydrogen will be necessary. This concept offers an alternative fuel type along with autonomous systems and sustainable designs for the future.